In the first part of the experiment, we showed that a pair of lenses, this 5 diopter and 2 diopter lens, at a distance of 5.1 meters apart, had the same focal power as a single 6 diopter lens. And in the second part of the experiment, part B, we're going to show you how to work out the focal power of a pair of lenses, and in general maybe 3 or 4 lenses if you really wanted to do it like that. Okay, and we're going to use a method called Newton's method. We use Newton's method, which is a bit more complicated than the usual way of measuring focal lengths, to get around a particular problem. We can take a pair of lenses and we can auto-collimate them as if they were a single lens. Okay, we just do it the normal way, like this. Okay, there we go. So we've got an image there, and so we've auto-collimated these. And that's a focal point there. Here's the problem though, what's the focal length? Is it from the focal point to the first lens? Is it from the focal point to the second lens? Or is it from the focal point to somewhere in between? And we just don't know. So what we need to do is we need to have a method for working out the focal length without actually directly measuring the focal length. And that's what Newton's method does. Newton's method needs 2 focal points, one on either side of the lens, and a pair of conjugate points. And from that you can work out the focal length. So we already have one focal point there, and we're going to call that focal point F, and it's at about 56.5 centimeters there. Okay, we need to have a second focal point, so we'll bring this over here and bring the light over behind it and auto-collimate again. And then we have a second focal point, which I'm going to call F prime, and that's at about 90 centimeters. Okay, so the next thing we need for Newton's method is we need 2 conjugate points. That's just an object and a corresponding sharp image. So we'll put our object about there, outside the focal point, and we'll bring in an image screen here, and we get a nice sharp image. So those are our conjugate points there, object, image. This distance here we're going to call x. This is the distance from the object to the first focal point. This distance here we're going to call y. This is the distance from the second focal point to the image. If we measure x and y, we multiply them together and we take the square root, that then is the equivalent focal length of this pair of lenses. And 1 over that is then the equivalent focal power of this pair of lenses. And you should get 6 diopters. After you've measured this, you can look at what happens when you change the separation between the 2 lenses, use Newton's method all over again, and work out the equivalent power of this pair of lenses at different distances, or you could use different powers of lenses if you want to as well.